We now go on to arrangement of electrons, also known as electron configuration. So this is the structure of an atom. Here in blue and red, these are neutrons and protons. Then in the orbits here, or in the shells, these are electrons that moves around the nucleus. So this is also known as electron configuration. The first shell contains only 2. It can only hold 2 electrons because it is the lowest energy. Then the next 2, which is the second and the third shell, can hold a maximum of 8 electrons. Since we are only interested in the first 20 elements of the periodic table, we can come up with this. Electronic configuration is equal to 288, 2 in the first shell, 8 in the second shell, 8 in the third shell. And this will help us group the first 20 elements of the periodic table into their respective groups. So knowing the arrangement of electrons is useful in understanding the structure of the periodic table. As we shall see, it also describes the chemical bond that holds atoms together. Let me highlight something here for lithium. Lithium is number 3 on the list of the top 20 elements of the periodic table. This means it has 3 protons, which are equal to 3 electrons. So in the orbits it has 3 electrons. Since we said that in the first shell, which has the lowest energy, we have only 2 electrons that can be held here, and the other electrons are in the next orbit, which is the second orbit. So here, since we have 3, we have 2 in the first and 1 outside. So this will be the structure of a lithium atom. So it's 2, 1. The order is 2, 1. 2 in the first and 1 in the second. Sodium has 11 protons, which are equal to 11 electrons. So we have 2 in the first. The symbol is Na. We have 2 in the first, which means we have 8 in the second. Then we have 1 in the third. 2, which is the maximum for the first shell. 8, which is the maximum for the second shell. Then 1, which is extra, which goes into the third shell. So the structure will be 2, 8, 1. Calcium, let's take calcium. Calcium has 20 protons and 20 which are equal to 20 electrons. This means the first word is 2, the second word 8 to make it 10, the third word 8 again to make it 8, and then we have 2 which are in the outer shell. So the order will be 2, 8, 8, 2. So we use these remainder electrons here to group our periodic elements. This means lithium is in group 1, and this means sodium is in group 1. This means calcium is in group 1. We just look at the last or the remainder electrons. If we don't have remainder electrons and the shell have the maximum number it can hold, it means we don't have an extra electron in the outer shell. That atom is said to be stable. So this is the periodic table. You can see here that we have many elements here. We start with the hydrogen. Hydrogen is ranked in group 1 because it only has one proton. Then here we have lithium, we have sodium, we have potassium, we have calcium here in the second group, magnesium in the second group, beryllium in the second group. Here we don't have groups, we ignore this. So this will be the third, fourth, fifth, sixth, seventh, then this will be the group 0, as we shall see in the next lesson. So this marks the end of our lesson. A few things to do and exercise. What's the importance of knowing arrangement of electrons. Demonstrate electronic configuration in aluminum, chlorine, and fluorine. Just look at your periodic table and demonstrate the electronic configuration.